Okay, so in our last unit, we were working with rational numbers, rationals meaning pretty much fractions, mostly in our mind, whether you realize that or not. And in this unit, we're going to be working with radicals. Most of you know these as square roots. Please stop thinking of them as square roots. Square root is not a generic term. So let's talk about what radicals are and why square roots are not a generic term. So in math, we have a way to do everything up. If we do it up, we have a way to undo it. So if I add things, I undo it by subtracting. If I multiply things, I undo it by dividing. If I multiply up polynomials, that means like foiling things out, I undo it by factoring, okay? So if I do things up by exponents, so 2 squared, 2 times 2 is 4, 3 squared, 3 times 3 is 9, or whatever, I undo that by roots. Okay, we do it up by exponents. We undo it by roots. So just as adding and subtracting are opposites of each other, exponents and roots are opposite of each other. Now the sign that we use, or the symbol, is called the radical sign. Okay? And one of the most important things that you need to know is inside this, what I call the V of the radical sign. The V of the radical sign. Its name is the index. So whenever I'm talking about an index, I'm talking about the little number inside the V of the radical sign. I'm going to say that one more time. Whenever I'm talking about the index, I'm talking about the little number inside the V of the radical sign. Now, if there is no number showing, it's an invisible number, that index, then that index, the little number inside here, is always a 2, meaning square root. Which is why I think we always assume that these are all called square roots, okay? Because every time we see one, we call it square root. But if it does not have a number in it, it's an invisible 2 that makes it a square root. Any other index must be in there in the V of the radical sign. So this one is a cubed root. This one is a 4th root. This one is a 5th root, meaning that the original problem for this guy was 2 the 3rd. This one was 2 the 4th. This one was 2 the 5th, etc. So I can have any root at all. So our generic term is roots, or you could call them radicals. Okay? But the actual term is roots, and the sign is a radical sign. So let's talk just a little bit about how this works. So if I have, let me do this, 3 squared, that equals 9. If I want to undo it, it would be the square root of 9 equals 3. We all know that. We're used to that. But then there's this. If it were 2 to the 3rd, that equals 8. If I want to undo it, it's the cubed root of 8 equals 2. And you notice how the exponent and the index are the same, okay? And that's how we talk about or work with. These are all the important things about radicals. Now we're going to learn all kinds of things about how to do radicals, but one of the things that I'm going to teach you now is called prime factorization. And if you learn this well, it will really make your life way, way easier. Okay? Prime numbers, okay, if you remember, take a minute to try and think about this, are numbers that only can be multiplied by itself and 1. That's it. So our first lowest prime number is 2, because 2 can only be multiplied by itself and 1. Then our next one is 3, because it can only be multiplied by 3 and 1. But then we have 4. That is not a prime number, because not only can I multiply that by 4 times 1, but I can also multiply 2 times 2 to get 4. 5 then is our next one. 6 is not. 7 is a prime number. Think about these. 8 is not. 9 is not, because I can also multiply 3 times 3. 10 is not. 11 is. 12 is not. 13 is. 14 isn't. Think about what can multiply besides 14 times 1. 15 is not. 16 is not. 17 is not. 17 is prime. The only thing I can multiply to get it is 17 times 1. 18 is not. 19 is, etc. Okay, now, one thing you want to notice, 2 is our lowest prime number, and 2 is an even number. After that, no other even number is prime, because every other even number after 2 can be divided by 2, or 2 times something can get that number. So all prime numbers after 2 are odd numbers, but that doesn't mean all odd numbers are prime. You notice here 9, which is an odd number, is not prime. 15 is not prime. There are lots of prime numbers that are odd that are not prime. But anything after 2, if it is prime, has to be odd. So when we're doing this prime factorization, we're only going to use prime numbers, and we always start with the lowest one and use it until we can't anymore. Then we use the next lowest one, etc. And I'm going to do as many examples here as I can get in. So let's talk about the square root of 16. We all know that's 4. But what if I did not know, at least I hope we all know that's 4. What if I did not know that that is the square root of 16? So I would do 16. Now I'm going to do not like we've been doing up till now, 1 times whatever, 2 times whatever. Okay, we're going to make a tree here. Okay, so start with the lowest prime number. Can that go into 16? It can. Keep going until all the numbers on the left prongs and the bottom are all prime numbers. When that happens, then I'm done. Now, I'm going to circle my prime numbers, and there's a big boss that tells me how many of the same prime number gets to be in the group, okay? And only the same prime numbers are allowed to be in a group. So 2s can't be in a group with 3s, and 3s absolutely refuse to be in a group with 5s, and 5s will have nothing to do with 7s, okay? This guy here, what's he called? Index, tells us how many of the same prime number can be in each group. So in this case, because it's an invisible number, it's 2. So that means, oh, maybe I'll leave that. So that means only 2 numbers can be in a group, okay? So now, when I have circled all the prime numbers, that means I have an even root, even. And all that means is I end up with a whole number with nothing left over. That's what an even root is, okay? So then what I do is I take one number from each group, so 2 times 2, multiply those up, and that's my answer. So the square root of 16, if I didn't know, I would look at that and I'd say, oh, 2 times 2 is 4. What if I wanted the 4th root of 16? Well, I'd do 16 again. 2 goes into it 8 times. 2 into 4, 2 times 2. But how many needs to be in a group this time? Well, our index says 4. So 1, 2, 3, 4 in a group. And make sure you're circling these guys. Those people who don't circle these almost never get this correct. Well, now, again, all my prime numbers are circled, which means this is an even root. But I only have one group. So I just take that one number, and that's my answer. Well, let's check it. This would be 2 to the 4th. Well, 2 times 2, well, so this is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Okay? Let's look at a few others. What if I wanted to do the square root of 2,000? Don't let big numbers freak you out. Just do as I've been telling you. 2 times 1,000, 2 times 500, 2 times 250, 2 times 125, 3 times, 3 does not go into that. But 5 does, and then 5 times 5. Excuse me. Okay, how many in each group? Well, I have an invisible 2 in here in my index, so that means 2 of the same number goes in each group. But look at this. I ended up with something left over. So that means this is not an even root, okay? So what I do now is take one from each group and multiply them together. 2 times 2 is 4, and times 5, so that's 4 times 5, so that equals 20. And because these guys are wrapped up in blankets, coats, whatever you want to think, I think of this radical sign as the house. They're allowed to go outside of the house. And then it's times, and then whatever prime numbers are left over, you multiply those up and put them inside the house because they didn't have a coat on and were not allowed to go out. So if I put into the calculator the square root of 2,000, I get this big long number, 44 point blah, blah, blah. If I put in 20 times the square root of 5, I get the exact same number. It's as if, and this is just metaphorically speaking, the square root of 2,000 were 3/12. I would never accept that because it's not in lowest terms. Lowest terms is 1/4. So the 20 times the square root of 5 is lowest terms of the square root of 2,000. I'm going to do some more examples in the next video.